Hi there. Welcome to Turbocharging Your Code Builds with AWS CodeBuild. My name is Brian Farnhill. I'm a developer specialist solutions architect with the public sector team at AWS, and I'm based in Canberra, Australia. Today, I'm going to take you through a bit of a rundown of the things the CodeBuild team has been working on throughout the year and the features and updates that have been released that are going to make it really easy to get more value out of your builds. We're going to talk through improvements to the environments. We're going to talk through reporting improvements that will make it easier for you to understand what's happening in your builds. And we're going to go through some of the integration improvements that let you call your builds in different ways and make it easier to connect CodeBuild to other things. And lastly, we're going to show you a bit of a demo of how some of these features look when you put them all together in the AWS console. So throughout the year, the team has been working on a number of different features. In February, they kicked off with EFS support, April, notifications in Slack. In May, there was support for step functions and unit test visualizations. In June, the team was able to release additional shell environment support and resource utilization metrics in CloudWatch. In July, support for AWS Session Manager and code coverage visualization. And in September, the coverage of an additional AWS region being Milan. So throughout this talk, I want to take you through some of these updates in a little bit of detail and explain how they will help you as builders in getting more value out of CodeBuild as a service. So I want to start with the improvements you'll see in your environments. So the first one to call out here is AWS Session Manager support. So what Session Manager is, for those who haven't heard of it, is it's a managed service. It's part of our Systems Manager suite of tools for allowing you remote access to an EC2 instance without having to open port 22 or for SSH access. This also means you don't need any SSH keys. It's a mechanism where you can use IAM to authenticate in through a secure control plane to connect to your instances. Now, the reason this is useful for AWS CodeBuild is that I can use it to connect to a CodeBuild environment and troubleshoot a build in the actual environment. So one of the challenges that customers let us know was that sometimes a build script would work fine on my machine, but I'd push it into CodeBuild and I would find some sort of error that was happening there. This became pretty hard to troubleshoot because the CodeBuild environments often would only exist for a few minutes while the build runs, which is great because I only pay for a few minutes worth of use, but harder to troubleshoot. So what this Session Manager support does for us is it gives me the ability to essentially pause a build. And we have a command for that called CodeBuild breakpoint. When you put that into your build spec in a build that you tell to have Session Manager support, what you'll see is the build will pause at that point and allow you to connect to it through a single click in the AWS console or using the AWS CLI. You can then interact with it using standard SSH connection. You can have commands to run command line tools and investigate that actual CodeBuild environment. And when you're done, you can use the CodeBuild resume command to be able to tell CodeBuild to keep going and going from there. So think of this in the same way as when you're debugging code. You set a breakpoint in your code, and when the execution gets to that point, everything pauses. You can investigate and you can check values of variables. You can do sort of ad hoc commands. And when you're done, you tell it to resume. It's exactly the same concept, but applied to your builds running in CodeBuild. So this is going to be able to help you solve some really complex troubleshooting that you might find yourself needing to do. Other improvements in the environments that I wanted to call your attention to, we have additional shell environments. So what this means is by default in the before this update, what you would have seen is a Linux environment, you would get sh as your command executor, and in Windows, you would get PowerShell. And this was great if your script worked in one of those two mechanisms. What we have now, though, is bash support in Linux and CMD support in Windows. So previously, if you needed one of these to execute your scripts, you could do it in a build spec. You could call out to bash from your standard shell script, but it required a little bit of extra jumping through hoops in those build specs to get to that point. Now you can natively call out that I want bash to execute my script, and it'll go through and use that for you, which means you've got a cleaner build spec that's easier to understand, and you've got the appropriate executor for your script. The other one is support for Amazon EFS. So EFS is our elastic file share if you're not familiar with it. It allows you to create managed file shares based off NFS that exist within a VPC in the cloud. What this does for CodeBuild is allows a CodeBuild environment to connect to one of those EFS shares. So scenarios where this might be useful are where you've got a build that depends on a large amount of data that already exists in an EFS share somewhere. Previously, you might have had to run scripts and commands to replicate that out via something like S3. Now you can connect natively to those EFS shares when you need that build to do it and manipulate the files and use them in your builds so that you can get the output you need with, again, less jumping through hoops. So this is pretty straightforward. It's got all the things you would expect it to have in terms of connecting to a VPC. So your code build will have a security group, and you need to make sure that your security groups will allow access to those EFS shares. You also want to make sure that you're leveraging that privileged build environment flag in CodeBuild. So this backs into the Docker settings for that privileged environment and is needed to be able to mount external devices, which is what your file share will present as. So make sure you've got that one selected, but after that, you'll have a directory that can map out to your EFS share and access to all of that data in your build environments. So let me talk to you about some of the improvements that the team has been working on around reporting. I want to start first with the visual reporting of tests. So we've always been able to use CodeBuild to execute different types of tests. And one of the great things about it is that it's really open about the different test tools you can use depending on the language you're using and the type of app you're building. But what was a problem was if your tests would fail, you would see that the build would fail and you would go through and handle that. But finding out what caused it to fail meant that you had to open it up and go into the logs and scroll through what could potentially be a very long list of logs to find the specific test that failed. So the information was there, but it was a little bit harder to access and it took you more time to understand where the failure came from. Using these visualizations, I can visualize both the output of my unit tests, so what passed, what failed, how long did it take for the tests to run, but I can also visualize the coverage of my tests. So I can look at how many lines of code were touched during my unit test run. And this gives me a really good idea about how much of my code is being tested, because having 100% of my tests pass when I'm only covering 1% of my code is probably not a useful metric on its own there. So if I've got a much higher percentage of code coverage and I can see the tests are green, it's highly likely that I've got a good testing regime set up here that will automate and help me understand what's working and what's not, and then quickly finding things out using these visualizations. Now, the way we do these visualizations is we use a number of standard formats in terms of both unit test reporting and code coverage reporting. So most of them are XML based. So you provide an output in one of those known XML formats, and CodeBuild can then take that, visualize the report for you, and make it really easy for a developer who's accidentally broken the build to go and understand how they did that. The next reporting improvement is the resource utilization metrics in CloudWatch. So CodeBuild has always had a broad range of metrics in CloudWatch that you could use for how many builds were running and to get a bit of an idea of how busy your build project was. What was missing, though, was the specific utilization metrics that can help you right-size and understand what's going on in your build. So, for example, if you're using a build server that is too small, you haven't given it enough CPU or memory, or maybe you've gone the other way and you've over-provisioned and you're paying for a really large build server when you don't actually require that. These metrics can help you understand that. So what it's going to capture for you are CPU usage, memory utilization, and disk I/O. So I can get these on a per build basis, assuming that the build is at least 1 minute long. Anything less than a minute, we're not able to capture these metrics for, but anything over a minute, you'll be able to see throughout the life of the build what the CPU, memory, and disk was doing. Now, the CPU metrics, we trace those in what's called CPU units, and you'll see two different graphs for it when you look at this. The first will show you the number of CPU units you've consumed, and the second will present that to you as a percentage. The units are basically the same concept of how we do this in ECS, where one virtual CPU equates to 1,024 CPU units. So you'll see that in terms of the specific measure, but the percentage gives you an idea of how much of it you're consuming. If I'm consuming 100% of my CPU, then I probably want to look at a bigger instance. If I'm barely touching it, maybe I can get away with shrinking this. But now I've got data to make an informed decision there, so I can right-size my builds to optimize for performance, so I'm getting a really quick build, as well as cost, so I'm not over-provisioning on my build servers. All right, let's get into some of the integration improvements. And there's been some really big changes here that are worth talking through. The first is the parallel and coordinated build execution. So there's a number of scenarios that customers have come to us with saying that I've got a complex set of builds where I have things that are dependent on other builds, or I've got lots of builds that need to happen at the same time, or some, even doing things in a matrix of lots of combinations of values. Basically, what was required before this feature was you needed to orchestrate this yourself. So you would use scripts, or you would call out to multiple Lambda functions, or any number of ways to essentially say, do the following sequence of things. Now with this feature, I can use the 3 different types of orchestrations that I've got on the slide here to control how my builds run and define it just in the build spec. So it's really easy to set up these sorts of things. The first one is a build graph. So this is around defining a graph of my builds where there are dependencies between specific builds. So looking at the visual beneath that, you can see that what will happen if I define a graph like this is build A will execute first, and then build B and build C will both execute after that. So there's a dependency between builds B and C and the first build A there. So I don't need to orchestrate that and say, wait for build A to finish. CodeBuild will handle that for me. The second option here is the build list. This is where I want to run a number of different builds in parallel. So again, I don't need to orchestrate running them all. I can define them very easily inside my build spec and let CodeBuild orchestrate that. Last is the build matrix, and this is where things get a little bit more interesting. You can define a number of different properties, such as different runtime versions, different environment variables, and other inputs there as well. And what CodeBuild will do is it will define a matrix of all of the possible combinations of the values you've specified. So in the example that I've got below here, I've said I want to use 2 runtimes, runtime A and runtime B. These could be, maybe I'm running with multiple versions of Node.js because I want to make sure that I can compile to different versions before I upgrade. The second one is around environment variables. So x equals y being the first one that I want to use. And the second one, I want to run it with x equal to z. So same variable, but different values. So what CodeBuild will do here is it will actually run 4 builds with each of the runtimes and then each of the combinations of those environment variables. So this gets really complicated, but I just define the combinations of these parameters and CodeBuild will handle the orchestration for me. So I can get into some very complex setups using just a simple text definition of that in my build spec, so that I can not have to put the overhead in of orchestrating these kinds of build setups. Next, we've got integration with AWS step functions. Now, step functions, for those of you who aren't familiar with it, is essentially our managed workflow service. It's a state machine workflow where I can do things like conditional logic and filtering out to different paths based on inputs that come in. So I can build out a workflow that says do step A, and then if x equals y, go down this path, otherwise go down the other path. So you can see there's a visual here to give you a bit of an example related to CodeBuild. We start off saying, should I run the build? And if the answer is yes, we go in and we trigger a build that should I run the tests? If the answer is yes, we go and run a build that runs the unit tests. And from there, we go and read the results back out. And if the tests pass, that's great. And if not, we can notify someone. Whereas back at the top, if I'm not going to run the tests, I could trigger a different build that won't actually execute those tests for me. And we'll then move on from there. So I've got the ability to interrogate values and make choices to go down different paths. So this means that I can orchestrate some really interesting workflows around my builds and how we're going to pick particular outputs and paths based on what I'm trying to do on the data that's come in. Now, one of the questions that customers have come to us with this, though, is they've said, look, CodeBuild is really interesting in step functions, but what about code pipeline? Because doesn't that help me orchestrate multiple steps? And the answer is that both of them can help you automate things, but they've got some slightly different use cases. So I want to spend just a minute or two talking through when you would use each of them. So AWS Code Pipeline is designed for releasing software through to production. It's got a mechanism called stages, which act as a locking mechanism to make sure that there's only a single execution at a time. So let me give you an example here. If I've got a code pipeline that's hooked up to my repository, and I send 10 commits through to that repository in a fairly short period, Code Pipeline will start the first one that comes through, and it'll begin the build and going through from there. After that build's finished, if those other 9 commits have all landed in there, Code Pipeline is going to intelligently select the most up-to-date version to go with next, which will be the last one that came in. So in this scenario, what might happen is the build will run next, and it'll skip commits 2 through 9 and go straight to that 10th one. Now, it'll still tell me that there's something that broke the build if I've got some sort of problem there, because the code build will still run, but I won't know exactly what commit it was. Whereas step functions is designed to run lots of things in parallel. Now, this means that I can run the build against every single commit and to do it all of them at the same time. So this works really well where I'm trying to do a continuous integration build, for example, where I want every single commit to run and provide fast feedback to a developer if they've committed some code that's going to cause us a problem. So the CI build works really well for those step functions. The other thing to think about here as well, that code pipeline is really good at things like manual approval steps. Without any additional work, we can connect them in very easily. And it's really good at multi-region, multi-account deployments. So for example, if I have an AWS account for my dev environment and a separate one for test and a separate one for production, I can define a single code pipeline very easily that releases my assets from dev to test to production. Whereas step functions, it's a little more focused on things happening within a single account. The other reasons that you might look at step functions will be if you're trying to integrate with other AWS services that support step functions. So there's things like ECS, EMR, Glue, there's a bunch of SageMaker things. There's more services than I could call out on this slide. But if your build needs to hand things off to one of these other services, you might have a good story there for leveraging step functions to get that done versus code pipeline. So give some thought to which one is the right thing for what you're trying to solve for. There's no one-size-fits-all response here, but typically if you're looking to release to multiple environments and release software to production, you'll go with code pipeline. If you're doing more ad hoc conditional processing stuff, step functions is likely going to be your friend. So what I want to do now to give you a bit of an idea of how this all comes together is to show you a quick demo of a number of these features at play so you can see what they look like in the AWS console. So let's go ahead and get started with the demo here. I'm going to start off by pushing a commit to a dummy repository that I've set up. And this is going to help me show how a continuous integration build can be called by step functions. Pay attention to the name of the branch that I'm committing to in here. It's called feature demo. It's going to be part of my conditional logic in the step functions in a little bit. I'm just going to push my commit through now, and I'm going to go and have a look at step functions in the AWS console. As you can see on the left here, if I just refresh this a couple of times, you'll see that I'm now running an instance of a step function based on that commit that's come through. I'm also leaving Slack open on the side here because it's going to show me when there's a failure in my build. Now, while we're waiting for that to run, let's have a quick look at the step function. What I've got here is actually a really simple demo of step functions. I've got some logic to check the branch name, and then it'll either run the build or skip the build based on that. In check branch, I'm using conditional logic that says only run the build when the branch name matches the naming pattern feature-something. So in my demo here, you saw I was feature-demo. And so the step function will choose a path based on that particular value. So if I come and have a look at the input that code commit gives me in here, it's actually pretty detailed about what's going on. I've got a lot of information about the commit, including the reference name and type being feature demo and branch. So I know that this is a commit that hit my specific branch. Now, while that's happened, my CI build has actually gone and failed. You can see the red light here. And across in Slack, I've got a notification that's told me something's gone wrong with my build. So let's click on that link in Slack and we'll jump in and have a look at what's going on. So you can see the details of my build here, and straight away I'm brought to the phase details view so I can see what happened and what failed. You can see here the post build activity is the one that's failed and the test command was the one that I had issues with. So this tells me that I need to go and have a look at my unit tests. While we're here though, I want to show you the resource utilization tab really quickly. So if we come into here, this is where I would see those CPU, memory, and disk I/O metrics that I was talking about previously. Now, these are only available for the builds that last more than 1 minute. The build that I've got in the demo here is designed to run really quickly, so I can include it in a bit of a demo, so you won't see the metrics here. But if I needed to see them, this is where I would go. It's just another tab in my build there, and super easy to get to. But let's go back to the build now, and I know that the tests were the thing that were causing me some problems, so let's go and have a look at the reports to visualize those and figure out what went on. You can see my build here includes both of the two different types of reports. I have my unit tests and my code coverage. I want to show you the code coverage report first. So as we open this up, you can see that my code coverage is quite frankly appalling. I'm only covering a single line of my code. But I get a really nice visualization here to sort of see how much of the code is being covered versus how much is not. And if you scroll down to the bottom here, I've got a bit of a detailed view that shows me the individual files and how many lines of code are being covered by my tests in each one of those files. So this can help me start prioritizing my work to build tests and get additional coverage for my code base where I need it. So it's a really great way to understand how effective my testing strategy might be against my code base. But rather than look at that, I'm more interested in the failed unit tests. So let's go in and have a look at the report visualization for that one. So you can see here that I have two tests, one that passed and one that failed, and I've got a visual that gives me an idea of what's happened there. If I scroll down, I can see the details of what's been failing here. It's called pointless environment variable matches expected value. So there's the test that failed. I can see the details of all of the tests that were run, and I've also got the ability to filter to view things like just the failed tests, which make it really easy for me to see what's going on and get to the bottom of what broke this particular build. If I go and select on that test as well, I can see the detail that was provided by the actual test. In this case, it was an assertion error, where it expected hello world, and it received not the right value. Now, knowing my code base, I know that that maps out to an environment variable problem. But when I ran this test locally, it worked on my machine, so why would it not work on CodeBuild? This is an ideal time to connect to the CodeBuild environment using that Session Manager feature and investigate those values in the actual CodeBuild environment to see what went on. So to do this, I need to start a new build. So let's go back to the build project and manually kick this off. I'm going to choose Start Build here to kick off a new build. And if you want to use Session Manager, you need to select this button here called Advanced Build Overrides. This is how you opt into using some of these features like Session Manager. This allows me to do things like put those breakpoint commands into my build specs, but not have it automatically pause every single build I try to push through. I'm going to choose the branch next, and I'll pick the one that I pushed my code to earlier. And then scroll down a little, I'm going to tick this box that says Enable Session Connection. So this is where I opt into that. You need to make sure that your build has the right IAM permissions for Session Manager set up ahead of time for this to work. But basically, this will tell CodeBuild to honor those CodeBuild breakpoint commands that I was talking about earlier. I'm going to leave all the rest of the defaults in place here and just choose to start my build. Now, what I'm going to do is just open up the logs to tail these here, and while that build runs, I want to show you the build spec file so you can see how we've done this. I've got a really important command in here, CodeBuild breakpoint. So I've set this to happen after the build has run, but it'll pause the build there before the tests have run. So this is going to be the best time for me to really investigate that environment and have a look at what's going on with those tests. It'll mean that I can interact with the environment before those tests have run and try to figure out the root cause of the failure. Now, while I'm here, I also want to show you the bottom here. I've got the report definition. So this is where I talked about those test reports from earlier. You can see I'm defining JUnit as the XML format for my unit tests and Clover XML for my code coverage report. Now, I'm also using a fixed name here. And so what you can see here is that it's going to pull testreport.xml. You can use naming patterns, though, to get a broad range of files if you've got lots of coverage. Now, hopefully by now, if I go back and flick over to the build, you'll see that, yes, we have paused. The build has paused and it's now ready for me to interact with that environment. So I'm going to look to connect to that using AWS Session Manager. So if we come back out here and have a look at what's at the top of the screen, you'll see AWS Session Manager. This is that single click button that I talked about earlier to be able to connect to one of my environments. So I'm going to select that to open a new session and just quickly open up a side-by-side view so you can see what's going on in my Session Manager terminal as well as what's going on with the build. So let's get into this, and I'm going to have a look at my environment variables here. I'm going to start by interrogating this and having a look at my pointless variable. And you'll see that it is, in fact, not the right value. So this means if I were to go ahead and run the tests right now, you'll see that I get the same failure that I was getting from CodeBuild executing those tests for me. So let's play around with how I would fix this. At this point, I want to update my pointless variable to hello world. And that should hopefully make my tests succeed. So you'll see if I run those tests again now that I get a successful result. So this is an example of how I could connect into that actual CodeBuild environment to start interrogating things and figuring out what went on. At this point, I'm going to go and run CodeBuild resume, and this is going to tell the build to take back from where it was pausing. So you'll see on the left after I run that the build continues to run, and it's going to go through and fail, which is what I expected, but now I know exactly what I need to do to go and fix this. So what I've shown you is actually just a really simple example of this, but hopefully you can see how you could solve some very complicated problems with it by being able to connect to the actual environments that CodeBuild is running. Now at this point, I could take what I know about that break and go back and fix it, which in this case, the problem was right in front of me the entire time. I just changed not the right value to hello world, and my build will go back to green and I'll start adding value to my application again. So to recap, what we saw was the Slack notifications, we saw step functions integrations, we saw where those resource utilization metrics would go, we saw the different types of report visualizations, and lastly, the ability to use Session Manager. So hopefully that stitches together a bit of a view how all of these features can help you add values to your CodeBuild builds. So to give you a bit of a recap now of what we went through in this session, we saw a number of improvements that's been made to CodeBuild throughout the year, with things like improvements to the environments, things like the reporting improvements and visualizations, and the ability to integrate CodeBuild into more different types of workflows in more places in AWS. And lastly, we finished off with that demo that showed you what these features look like when you put them to use. So next steps, start exploring. CodeBuild's got a level of usage available in the AWS free tier. So I encourage you to start having a play around with CodeBuild and seeing how it can work for your builds and your projects. Start testing and debugging builds, and go and have a look at CodeBuild Local as something that can help you get your builds right before you start using the CodeBuild service. And lastly, to stay up to date with the latest happenings around CodeBuild and all of our code-related services, make sure you sign up for things from the AWS DevOps blog to get all of the latest news and updates. Thank you so much for spending your time with me today. Hopefully you've learned a few things about CodeBuild. If you'd like to reach out to me on Twitter, there's my Twitter handle. And lastly, please make sure you complete those session surveys. We really do take the feedback into account in planning these events and making sure they're what you're after. Thank you so much for watching, and enjoy the rest of the reInvent content.